Okay, so when it comes to trigonometry here in Chapter 8, these are a couple things to keep in mind. These ratios only apply to right triangles, right? So just like Pythagorean theorem only applies to right triangles, trigonometry, the same thing. They're ratios of sides in a triangle according to a particular angle. Like, for example, if angle R up here is a 30-degree angle, okay, then the ratio of ST to TR, or side R to side S, that ratio is going to be the same. It doesn't matter if I make R bigger and S bigger. If I keep that as a 30-degree angle, that ratio is always going to be the same. And we call that the tangent ratio. It's the opposite side over the adjacent side. Likewise, if R is 30 degrees, if that angle never changes, then the ratio of S to T would be the same. That's the adjacent over the hypotenuse. Side T is the hypotenuse. We call that the cosine ratio. And then finally, also the ratio of R to T, the opposite side to the hypotenuse, that would remain the same as well. We call that the sine relationship, and it's expressed this way. So when I look at, if I'm sitting here at angle R, and I look at the side opposite R, which is little r, and the hypotenuse, which is T, we call that the sine ratio. Okay. For cosine of R, again, I look at the adjacent side, which is S, and also the hypotenuse. So in both of these cases, notice the hypotenuse lives in the denominator in both of these. And then when we get to tangent, we don't use the hypotenuse at all. We use the opposite side R over the adjacent side S. Okay. So what we can come up with here is a little acronym to help you remember this. For sine, we have the opposite side over the hypotenuse. Okay. So we call that SO. And just hang with me. For cosine, what do we have? The adjacent over the hypotenuse. Adjacent over hypotenuse. And then for tangent, we have the opposite over the adjacent. So it's a kind of an easy little acronym for you to memorize and remember those ratios. SO, CA, TOA. Okay. There's lots of fun little stories that go along with that. But just remember that it's SO, CA, TOA, and you'll be able to remember that those ratios as we unpack them. Okay, so let's start with the first thing I want you to be able to do in each of these triangles. I want you to look at each angle, J and L, the two acute angles. We don't ever do any of these for the right angles. So in each one of these three triangles, we're going to look at J and L, and we're going to look at what the sine, cosine, tangent relationships are for each one. So I start in number 1 here, and I want to start with the sine of angle J. Okay. What's the sine of angle J there? So remember that acronym that we have, SO, CA, TOA. I'll write it over here. So that helps us remember for sine, we want to look at the opposite over the hypotenuse. For both sine and cosine, the hypotenuse is going to live in the denominator. So I can put the 20 there right away. Okay. So if I'm up here at angle J, what side is opposite, 16 or 12? It's the 12. Okay. So if I simplify 12 over 20, I can divide both of those by 4, and that would be 3/5. That would be my sine ratio from angle J. Cosine from angle J. Okay. Again, I know the hypotenuse has to live in the denominator, so I'm going to put it there right away. All right. So again, I'm up at angle J. What's the adjacent side from angle J? 16. Again, we can divide both of those by 4 and simplify that fraction to 4/5. Okay. And then finally, I have the tangent of J. And now remember, for tangent, the hypotenuse does not live in the denominator. Okay, what lives in the denominator for tangent is the opposite side, which here is 12. So 12 is opposite. Adjacent lives in the denominator. TOA, right? Opposite over adjacent. So 16 is down in that denominator. And the adjacent side, or the opposite side, is 12. It's the opposite over the adjacent. So if I'm up here at J, opposite of J is 12. Adjacent is 16, so I have 12 over 16. Again, divide both of those by 4, and we would have 3/4. So I have the sine of j is 3/5, the cosine of j is 4/5, and the tangent of j is 3/4. So now I want to do the same three ratios, but I want to do them for L. I want to take the sine of angle L, cosine of L, and tangent of L. And I'm going to use that same SOHCAHTOA acronym. So the sine from L is going to be here. Remember, hypotenuse lives in the denominator again, all over again. So we have 20 for the sine of L is going to be in the bottom. So from L, where's the opposite? Now it's 16 over 20. If you notice, the sine and cosines for L and J just switch, right? The numerators just change. So now we have, divide both of these by 4, 4/5. That was the cosine of J. It's now the sine of L. Okay. For cosine of L, 20 is going to be in the bottom again. Okay. And then the numerator is going to be the adjacent side, which is 12. And again, you see that they just switched from J to L. We had 3/5 and 4/5 respectively. And then they just switch. And the same thing's going to happen to tangent, right? Our tangent of J was 12 over 16. Now it's going to be 16 over 12 for L. We want the opposite over the adjacent, so we just switch those. Divide both of those by 4, and we have 4/3. Okay, so we'll add one more here. I'm going to go ahead and skip number 3 today. But let's just look at sine J, cosine J, tangent of J for the next triangle. Right? Same thing that we just did. Let's start with the sine of angle J. And again, right away, we can throw that hypotenuse in the denominator. We know sine is always going to be a hypotenuse in the denominator. So what happens at J? Remember SOHCAHTOA. Okay, so we want the opposite side from angle J, which would be 24. And I think I can divide both of these by 8. And we have 3/5, similar ratio to the last one. Cosine of J. Right away, when I have sine and cosine, I'm throwing that hypotenuse into the denominator. Let's get used to doing that right away. Okay, so at J, what's adjacent to J? 32 is adjacent to it, right? Adjacent means next to. 32 is right next to him. 24 is opposite from him. Divide them both by 8, and we have 4/5. So this triangle is similar to the triangle we just did, so we get the same ratios. Tangent J. Now, adjacent lives in the denominator, right? So what's adjacent to J? 32. Opposite is 24. Divide them both by 8. This triangle is just the previous triangle multiplied by 8, and we have 3/4. So now I want sine L. Okay, so we look at L. We know hypotenuse lives in the denominator right away, and we want the opposite, right? SOHCAHTOA, so opposite over hypotenuse, 32 over 40. Divide them both by 8, and we have 4/5. Cosine now from L. These are just reciprocals of the previous angle, J. 40 is in the denominator. Now we're adjacent to L, which is 24. Divide them both by 8, and we have 3/5. And then finally we have tangent L. So tangent to L is the opposite over the adjacent. Adjacent to L is 24, and opposite from that is 32. Divide them both by 8, and we have